Today we're starting in section 7.4. So we just finished up 7.3. Today we're going to do 7.4. 7.4 is about special right triangles. It can be a little bit complicated. I hope that we will go fairly slowly and it will be not too bad. Okay? So today our objective, we're going to be able to analyze special right triangles. Okay? Analyze special right triangles. And there's two special kinds that we're going to talk about today. There are two special triangles that we're going to talk about today. Yes, you can turn. It's already off. You can try it. See what people. Throw it off. See what people think. On or off?
Oh, good.
All right. Leave it off. Then. That's fine. No sleeping. Today we're going to talk about these two triangles. All right. These two triangles. The first one is called the 45-45-90. 45-45-90 triangle. And the second one is called the 30-60-90. Okay? These are both provided in your textbook. Both of these pictures. Okay? And they're provided in section 7.4. You will need to memorize these by the quiz. The quiz will tentatively be Thursday. Okay? Tentatively be on Thursday. So you will need to have those memorized by the quiz. But we're going to do a lot of practice, so hopefully it won't be too bad, okay? So these are what we're going to talk about for this section. These two special triangles. Do you want to copy these down?
Yeah.
Okay. Ernest? The 90 is right here. Remember that a right angle is 90 degrees. So Ernest asked, he looked at the first triangle, he saw 45, 45, and he said, where did I get the 90? Well, the 90 is right here at the right angle. Notice that these names refer to the angles, okay? So the first one you have a 45, 45, 90. The second one you have a 30, 60, 90. Gloria?
Are you going to give us a class?
I have a few people still have to take it. Sorry. So please copy those pictures down. The following people I'm missing quizzes from. Lionel. Just Lionel. Sure. Alright, if you're not finished, I'm sorry, but you can always look it up on the internet or in the textbook. Today we're going to talk about the 45, 45, 90. And as I discussed already a little bit, 45, 45, and 90 refer to what, Ernest? What? The degree or the angle measure? We talk about the degree or the angle measures. Okay? The hypotenuse, in this circumstance, how do we find the hypotenuse? There's two different ways. One way, Mauricio.
The cross from the right angle.
It's across from the right angle. What's the other way, Javier? Excuse me? We can use the Pythagorean theorem once we know what the hypotenuse is, but first we need to know how to find it. So one way is it's across from the right angle. What's the other thing that we always know about the hypotenuse? Jose? It's the longest side, so it's always the longest. Okay? So in this circumstance, my hypotenuse is right here. It's across from my right angle. And you notice it's longer than the leg. Here's the leg. How much longer is it?
2 times.
Not 2 times, because 2 times would be 2x. And that's not what we have here.
1 time.
How much bigger is it? It's not 2, it's
1.
What is this?
Square root of 2.
It's square root of 2 times bigger. So the hypotenuse is square root of 2 times bigger. Okay, that's very important. It's as long as each leg, right? In this case, notice that your legs are exactly the same, so it doesn't matter which one we pick. They're both x, or they're both the same length. Okay? So if we were to write this as a formula, we could say that the hypotenuse equals the leg times what?
Leg.
square root of 2. So the hypotenuse, the long side, is equal to my shorter side, the leg, times square root of 2. And you can see that right here. X is my leg. To get to the hypotenuse, I need to multiply it by square root of 2. Okay? Are there any questions about that? Now, that seems a bit magical. So where do these values come from? Where do they come from? Draw a square. Draw a square. And I want you to draw a square with side length of x. So that means that each side then has to be x units long. There's my square with side length x. Okay. I'm going to show you where this triangle came from. Ariel, eyes on me, please. I want you to cut the square in half grilled cheese style. Alright? So triangular. Alright? So like a grilled cheese, you might cut it into 2 pieces. Alright? And everybody knows the triangle slices are better. Okay? And now, if you see this red triangle, we still have the right angle, which is right here. We took these 2 sides, which are both x, and when I cut the 90-degree angle in half, how much is left then? Which is 45 degrees. So I get 45 degrees. So you notice that we have the same triangles as the page before?
Yeah.
Now, where did that x square root of 2 come from? That's what I'm trying to figure out. So if I'm looking at this in terms of the Pythagorean theorem, my 2 legs are A and B. And what's my hypotenuse always?
C squared.
C, not C squared yet. Okay. Ariel, second warning. All right, one more and I'm going to kick you out. Okay? If you need to turn your chair so you can see me, do it. All right? Now, in this circumstance, we have a right angle and a right triangle, so we can use the Pythagorean theorem. What is the Pythagorean theorem, Julian? Pythagorean theorem. You forget? Who do you want to call on? You pick somebody. Ernest? A squared plus B squared equals C squared. Alright? What's my value of A I need to plug in? Come on. X. So this becomes x squared plus B is also x. So it's x squared equals. And we don't know C, so I'm just going to leave it as a C for now. Okay? So this is what we're trying to find out. What is C squared? Okay? Now, x squared plus x squared gives you, you have 1x squared, whoops, 1x squared plus 1x squared gives you what, Brian? 2x squared, very good, equals C squared. Now, I don't want C squared. I want to know what C equals. So, Javier, how do I get rid of the C squared? I disagree. I disagree. What's the inverse of a square? Thank you. So I take the square root of both sides. Okay? On the right side, I have the square root of a square. So what do I get left? I just get C, because they cancel out. Does that make sense? C. Right? On the left side, what I want you to do is break it apart. So this becomes square root of 2 times square root of x squared. Remember our rule for radicals. You can multiply together 2 radicals if they're both underneath. And if they're both outside, you can multiply them together. So in this case, I'm just going to pull them apart. If they're both underneath the radical, keep them both underneath the radical. Does that make sense? Okay? Here, can we do anything with the square root of 2? Is that a perfect square?
No.
No? So carry it down. Times, what do I get with the square root of x squared? Just x equals c. And then my last step is I'm just going to rearrange. So I'm going to switch this order. Not 2 squared. What's that called, Marshall? Square root of 2. Good. So you get x root 2 equals c. All right? X root 2 equals c. And that is where we get that value. X square root 2. Patricia?
In the fourth line, why doesn't the square go to the 2 and it only goes to x?
2, 3, 4, right here.
Yeah.
Because whenever you're presented like with a problem like this, the exponent only goes to the base that's right next to it. If it were a problem like this, 2x squared, then it would go to both of it. You need the parentheses. Okay. Ernest? You may. So how do we do these problems? I've included the triangle for you. Right? I've included the triangle for you. Marshall, question? I've included the triangle. All you need to do is remember your formula that we started with. Marshall? What is the formula? Not the Pythagorean theorem. We just used that to prove. We just used that right here. Sorry. What does the dot thing mean? Multiply. So it's hypotenuse. 3 letters. I'm going to put leg. Okay. Very good. Yeah, it's too loud, please. Julian. So the hypotenuse is equal to the leg times square root 2. Okay? In this situation, what is my 8? Is that a leg or a hypotenuse?
Leg.
A leg, good. Because my hypotenuse is over here. So all you need to do is plug in your value. So the hypotenuse, do we know what it is?
No.
No. The hypotenuse is equal to, the leg value is what? 8 times square root of 2. Wherever you have a times square root of 2, you can just write them together. So the hypotenuse is equal to 8 root 2. This is exactly the same as 2x. 2x means 2 times x, but we don't put the dot in between them. Right? So 2 times x is the same as 2x. It's the same thing as what we just did right there. Marshall? Then it would not be this special type of triangle. Marshall asked, what if there was a 9 over here? How would you know which one to pick? And this is a great question. Remember, if the 2 angles are both equal, then the 2 sides must also be equal. So therefore, 9 would not be correct. And in fact, what does the side have to be? 8. Okay? So for a 45, 45, 90, you're always going to have 2 legs that are equal. And then your hypotenuse is going to be times the square root of 2. So notice, 1 second, Alicia, and I'll get you. Notice our answer. We have 8 root 2. Notice our formula triangle. X root 2. See how those are similar? Okay. Alicia? Because remember the formula that we left on this page from the very beginning, right there said that the hypotenuse is equal to the leg times the square root of 2. Okay? So I just went up here, and I started with that right at the top. The hypotenuse is equal to the leg times root 2, and then I plugged in the values I knew. Okay? Let's do another one, and I want you guys to practice on your own. Ryan, get started, please. Jason, get started. You know? You should not need a calculator. Anthony? Okay. 10 more seconds? Then I'll go over it. Okay, yeah, I've got it. Alright. You guys should all be able to set this up at this point. What is my formula, Evelyn, that I need to use for these triangles? Brian. Maria, up here, please. What is the value? What have I given you? Are these legs or are these hypotenuses? Legs. So I'm going to plug in hypotenuse is equal to, Anthony, 3 root 2 times root 2. Did everyone get to this step? Okay, good. What you probably got confused about is what to do here. Remember, if it's underneath the radical, you can multiply them together. If they're outside the radical, you can multiply them together. You cannot multiply an inside times an outside. Okay? So if you look at what we've got, we have a 2 and a 2. Both of those are underneath the radical. Does that make sense? So I say that the hypotenuse is equal to 3, because it just has to carry down. There's nothing there. And then multiply. What is 2 times 2? 4. And keep it underneath the radical. Does that make sense? It started underneath the radical. It must end underneath the radical.
So don't simplify it.
Okay. Now, this is a unique case because what is 4? What's that called when it can have the square root? Perfect square. What is the square root of 4? 2. So I can say that the hypotenuse is equal to 3 times 2. So therefore my hypotenuse must be 6. Okay? Any questions on that problem, Gloria? What would you like me to have skipped?
So far.
Because that's the final answer. You have to simplify it. Any questions before I move on to a new one? So I know my final answer then. This must be 6. By the way, if these two sides are equal, what do I know about the opposite angles?
They're equal.
And therefore these must be 45, even though they haven't been given to us. Ernest.
Without getting the answer, you can actually multiply 3 into 2.
Yes, but that is true. However, that doesn't work for, that works for 45, 45, 90s, but it does not work for for the next one, 36 and 90. So be careful. Be careful. Okay? Here you are. Problem's a little different. Because what have I given you this time? A hypotenuse. So set it up. Set it up. Same thing. We plug in for our hypotenuse. Can everybody get to this step? Everybody okay with this step?
Yeah.
Okay. We want to find out what the leg is, correct? You could have put an X there. That would have been fine. I probably should have. Let me put an X there. X times square root 2. Remember, Brian, Jason, last warning, I'm really going to kick you out if I call your name again. All right? Remember, if I have 2x equals 8, what do you do to get rid of the 2? You divide both sides by 2. So if I have x times square root of 2 equals whatever, what do I need to do? Divide, but this time I need to divide both sides by square root of 2. Okay?
What? Can you do that all over again?
Let me say it slowly. Yeah, so Alicia can explain it if you guys will all listen, Ariel.
Wait.
Go ahead.
Okay. So when you do, alright, so when you do like 2x, you divide both sides by 2, so you get x. You're gonna get 4. So basically you do the same thing. It's the same process. You just have a different type of form of number. Yeah, those cancel out and x is equal whatever that is divided by 2.
8 was just picked randomly. Just an example.
Okay.
Okay. So note that in order to get x by itself, we need to get rid of the square root of 2, right? And in order to get rid of the square root of 2, we need to divide both sides by the same number, so square root of 2 in this case. Whenever you divide a number by itself, what happens? It cancels. So I do it again over here. It cancels. I get 5 equals x. Is that going to be the same for both legs? Yep. 5, 5. Note the similarities. Note the similarities. 5, 5, 5 root 2. X, x, x root 2. Okay?
So,
Hang on.
okay.
Quiet, please. It's been much too loud today. Put on. Gloria?
Is that fun side?
Find the side. Yes, this is find the leg.
Yeah, the side. And then you're going to show us
We found everything now. We have all the sides.
You don't know the, yeah, you don't know the angle.
Oh.
That's what I mean.
Well, if these two are equal, what do we know about these two?
What about it?
That's it. Sorry, I skipped that.
Yeah. And the hypotenuse, the side.
Yes. Ladies and gentlemen, it's incredibly disrespectful when I'm trying to answer a question up here and I can't hear her. Okay? Jason, I realize you have a question, but you cannot shout out my name. What is your question, sir?
Also, was leg equals number for the hypotenuse?
Exactly. If it's a square root of 2. So Jason has noted that the legs always equal the number in front of the square root of 2. That only works if it's something square root of 2. Okay? And it only works for a 45, 45, 90. Ernest, you have attention for chewing gum.
Oh.
All right? Last one. Please do this the long way. Let's do it the long way. No. Javier, get started. Is everybody okay to this step? Is everyone okay to this step? What do I need to do here, Ariel?
You have to multiply what's inside the...
I disagree. Notice that there's an equal sign between them. What did we just do on the last problem, Ariel, whenever we had this situation? You divided by what? And why do we divide by square root of 2? Because we want to get what by itself? X. Good. So do it to both sides. What do I get left with on the left side? 2. This cancels. I just get 2 equals. So therefore these two must both be 2. Patricia?
Why do we have to do the math? Why know that?
Patricia asked if we know the shortcut, the one that Jason pointed out, why do you have to do the math? You really don't. My warning. My warning is it's good practice to do the math because the shortcut doesn't always work. Let's say that this hypotenuse was 8. Well, now it becomes a lot more difficult, right? There is no shortcut anymore.
But if it's 8, it wouldn't be 45.
Sure it would. But these just wouldn't come up as numbers.
Then you just divide by the whole square. Square root of 2.
Yes.
Then you just have 8.
You can have just an 8 in the hypotenuse. Absolutely. And we're going to do a practice problem that has that on there. Okay? Let me erase this. Any questions on this? Alright, what I'd like you to do is please get out your worksheets that we worked on last week. On one side it says 7.3, on the other it says 7.4. If you do not have it,
The only thing that's 7.1 I'm going to I don't remember how I got it.
get out the worksheet that I'm handing out to you right now. Sorry.
I'm not letting him. Yeah.
Listen carefully, please. Listen carefully, please. I would like you to do the following problems. 7.4, which is the back side. I would like you to do 1 through 6. And I will give you a bonus if you complete number 13. 1 through 6, and I will give you a bonus if you complete number 13. Stop. Stop. I have not finished my instructions. I want this to be completed on loose leaf with your name on it for every person. If you write in pen, I'm taking off 1. Alright? You have 15 minutes to complete this, and I expect 1 through 6 at a minimum to be complete. Okay? On which side? 7.4. 7.4.